all about Earth's core. The materials that make up the Earth settled into different layers. Humans live on the cool, brittle crust at the surface. Below the crust is the mantle, which is partly solid. The core is the very hot, very dense center of our planet that sits about 2,900 kilometers, or 1,802 miles, below Earth's surface. When Earth formed about 4.5 billion years ago, the whole planet was a ball of hot rock. Over time, the ball got even hotter, in part because of heat from the space rocks that smashed together to make the planet. The melting point is the temperature at which a solid changes to a liquid. After about 500 million years, the Earth's temperature heated to the melting point of iron, about 1,538 degrees Celsius, or 2,800 degrees Fahrenheit. This important moment in Earth's history is the Iron Catastrophe. During the Iron Catastrophe, the hot, melted rock at the middle of Earth began to move faster. Light material like minerals, water, and even air floated up and became the early mantle and crust. Iron, nickel, and other heavy metals pulled to the center of the Earth and became the early core. This core has stayed hot over the billions of years since. Every kilometer you go down, it gets about 25 degrees Celsius hotter, or 1 degree Fahrenheit per 70 feet. The core will never freeze over. Scientists estimate it would take about 91 billion years for the core to completely solidify. The sun will burn out long before that time. Two-layered core. The core has two layers, the outer core and the inner core. The hot outer core is mostly liquid iron and nickel. The inner core is mostly iron. Very high pressures that push on the inner core so that it is a solid, even though it's very hot. The core also holds other chemical elements that dissolve or spread evenly throughout into melted iron. For example, gold, platinum, and cobalt are much rarer on Earth's surface, but are found in the core. Another key element in Earth's core is sulfur, the same element that makes rotten eggs stinky. In fact, nearly all of the sulfur on Earth is found in the core. The large amounts of sulfur, a relatively light element, explain why the core is lighter than it would be if it was just nickel and iron. Growth in the inner core. We know that the core is the hottest part of our planet. Temperatures range from about 4,400 degrees Celsius, or 7,952 degrees Fahrenheit, to about 6,000 degrees Celsius, or 10,800 degrees Fahrenheit. The boundary separating the inner core and the outer core is the hottest part. There, temperatures reach 6,000 degrees Celsius, or 10,800 degrees Fahrenheit, as hot as the surface of the sun. As the entire Earth slowly cools, the inner core is growing by about a millimeter every year. It grows most around subduction zones, which are places where the crust pushes down into the mantle. Scientists also recently found that the inner core itself has a core, the inner core. This strange feature is as different from the inner core as the inner core is from the outer core. Earth's magnetic field. A magnetic field is the area surrounding a magnet where you can observe magnetic forces. Other planets, like Mars and Venus, have weak magnetic fields, but the Earth has a stronger magnetic field. The outer core causes the magnetic field around Earth. In order for this to happen, the planet must rotate or spin around, and it must have a fluid in its center that moves and can conduct electricity. The liquid iron in the outer core is an excellent electrical conductor and creates the electrical currents that power the magnetic field. Life on our planet needs a magnetic field to survive. It protects the planet from solar wind, a flow of charged particles coming from the sun. Without this field, solar wind would strip the ozone layer from Earth. The ozone layer contains gases like oxygen and protects life from harmful ultraviolet radiation, a form of energy that comes from the sun. Earth's magnetic field is mostly stable, yet it shifts all the time and the magnetic North Pole moves every year. Every 200,000 to 300,000 years, the magnetic North and South Poles can even switch places. Studying the core. Geoscientists who research the Earth and its processes cannot study the core directly. Most core research has been conducted by measuring seismic waves, the shock waves released by earthquakes. Seismic waves help show that the core had a liquid outer layer and a solid center. Meteorites, space rocks that crash to Earth, also provide clues about Earth's core. Most meteorites are pieces of asteroids, rocky objects that orbit the Sun between Mars and Jupiter. Asteroids formed about the same time and from the same material as Earth. Studying these meteorites can give a peek into how our solar system and the Earth's early core formed. In laboratories, scientists can mimic the temperature and pressure of the core using lasers and diamonds. Computer models also allow scientists to study the core, as they are programs that run on computers that simulate or imitate something that happens in the real world. In the 1990s, computer models beautifully showed how the core can flip Earth's poles.